Okay, my name is Ryan Harris,
And this is Aaron Rogers.
and this is our project for beginning programming. So, the project that we decided to do was a Hangman game, and we have coded it in Java, and this is our source code that you're looking at right now. And we're both going to walk you through how we set this up and what the source code looks like and what each individual part does, and then we're going to play two games, one where we win and one where we lose. And those are the two games that are going to be shown to explain how the game works. Alright, so let's get into it. So, we've set up here, before anything else, we've established our variables that are going to be critical to the source code running properly. So, and we've declared them outside of the main method. So they are all static methods, which means that they are associated with the class and they can be used throughout the program, not just within methods, but anywhere throughout the program. So first of all, and arguably the most important, is this first method, not first method, first variable, which is our static string. And this string array is called word list, and it's listed all of the words that the computer can choose from in order to display a certain word that the user has to guess. The computer can choose of any of these words that we've set up here. And then the second variable is called static string, and we've declared the name. We've called it random word. Random word is going to be the word that the computer randomly chooses from this array of words that we set up here. And then our third variable, static char array, this is the secret word. So this is what the user will see displayed on the screen, but it's going to be encrypted with underscores, and we're going to get into that in a little bit. And then obviously the next variable is our setting up our keyboard, so the user can enter something to the console and the computer will read it and plug it into the program. And then we have another static string called user input, and this is what's going to be used to read input from the user. And then the next variable, static int, mischance. So mischance is counting how many misses the user has missed for the game. So if they missed one time, later on the program, we've set it to 0. It has to start at 0. But later on the program, let's say the user misses 3 times, then we're going to increment this and it would go up to 3 in that example. But for right now, we've set mischance to 0. And then the next variable is another character array called mist, and we've set it to 8. So there are 8 spaces within this array, but it's an empty array at the moment because the user hasn't missed any. So this array is going to store all of the misses from the user. And then the next variable is the last few variables are booleans, and this is going to be the core logic of how the program is going to run. So the first variable is called letter found. It's if the user finds or guesses a correct letter. That's our first boolean, and right now we haven't set it to anything, but we will set it to either true or false later in the program. And then the static boolean solved, we've initially set it to false because until the user gets to the end of the game, right, they will not have solved the puzzle until they've guessed all of the correct letters. So we initially set it to false until the end of the program. If the user wins, then we'll set solved to equal true. Okay, so let's get into it. So we've established the main method, and we're going to have some other methods later on the program, but for right now, this is the core logic of the program that we've established in the main method. So right here, the first one, random word, we've set random word to have the values inputted into the random word, which is word list, which is what we've pulled from up here. So word list is, again, remember, the array of random words. And we have it to where the computer can choose randomly what word to do. And we use an integer type conversion, and we use the math.random method. And then we times it by the word list dot length of the array to choose any of the words within the array. So that is the logic for how the computer is going to choose a random variable, or a random word. Yeah, a random word, I should say. All right, and then the secret word, we're going to set that equal to a new character array, and this character array will be the random word that the computer chose and the length of it. So, and we're doing this because we have to have the characters individually, so we can compare the user guess, because the user guess is only one letter. So we have to set it equal. We have to set this equal to characters, so the computer is reading it like a character as opposed to a string, because the user is only entering one letter. Okay. And then we have our first for loop that is encrypting the secret word. So this is basically setting up the secret word to be encrypted. So the user doesn't know what the word is. All it can see is underscores, but the underscores is the length of the word. That's why there's random word.length up here in the for loop. Is so the user can see how long the word is, but it's encrypted with underscores, so they don't know exactly what the word is, but they can see how long it is. So that's what this for loop is doing. And then down here is just setting up the rules, explaining what the game is, how many chances the user gets. The user gets 7 chances, and we're going to use some of this logic to decrement how many chances the user has left. And then the core of the program is right here. Everything is contained within this while loop. So while missed chances is less than 7 and it's not solved, we're going to continue this loop. That's how it's going to function. So we have a couple of for loops that we've set up here. The first for loop is to print the secret word to the console. So this is just printing out the secret word. Up here, we set up encrypting the secret word, and this other for loop is just printing it to the console. So that's all this for loop is doing. And then this one is misses. So this is initially printing the character array of misses. And right now the user hasn't missed any, so it's just an empty array, but it's just printing how long it is. So how many chances the user gets to solve the puzzle. So that's all this that's all this for loop is doing, I should say. And then down here we have guess. Guess is just setting the user input to equal the keyboard. So it's just the scanner reading the user input for whatever letter they entered in. And then we're essentially setting the Boolean letter found value. We're going to set it to false because we're going to assume in the beginning that the user is going to answer incorrectly. So we're initially going to set this value to false, this Boolean. Okay, and then this next for loop is if the user guesses a letter correctly. Okay, so this is the logic if the user guesses a letter correctly. We're going to set up a for loop. And like a lot of the other ones, we're going to set I to 0. As long as I is less than the length of the random word the computer chose, then we're going to add I, and we're going to continue the loop. And then we have an if statement contained within this. That is the logic of if the user guesses a letter that matches one of the secret word letters. So if the user input, we have to use character at 0 because the user is only entering one character, so we have to set it to 0. And if the user letter equals the random word character at, so it's incrementing through the entire random word. If at any point the user letter matches the random word letter at any point in the word, it will equal it. And if that condition is met, then the secret word will equal the random word character, and it will display it on the screen. And then we'll set the Boolean letter found to true because the user did find a letter, so we set that value to true. Okay, now here's the logic if it's wrong. If it's wrong, the letter is not found, and we increment the missed chance variable that we declared earlier. And if you remember, we set up at the top, we set up a char array called mist, and it had 8 spaces within it. So if you come back down here, we pass in the value of mischance. So let's say mischance is 1. The user has missed 1. Then it's going to index it at 1, and the user input is going to be the letter. So this is the letter. And it's going to index the user guess that was incorrect into this array, and that's going to be displayed to the console. And then the last part of the missed value is displaying the hangman method, which is the picture of the hangman that we're going to discuss a little bit later. And then down here, we establish a hidden count, and the hidden count matches the secret word length. So this is basically incrementing the hidden count for however long the secret word is where the hidden count is. And this is the logic involving if it's solved or not. So if the hidden count is greater than 0, it hasn't been solved yet. But if it's not, then the puzzle has been solved. So essentially, this logic is for the end of the game if the user solves the puzzle or not. And then down here, you have, towards the end of the game, this will tell you at the end of the game if you ran out of attempts or not for solving it. 7 minus mischance. Remember, we're incrementing mischance depending upon how many times the user missed a guess or not. And then this for loop down here, it's just we're reprinting the secret word. So this will just print the word at the end of the game, assuming if the user missed it or not. So if the user failed the game, then this for loop will print the word to the screen showing the user what the word was supposed to be. So finally, if the user guesses all of the letters correctly, then it'll print solved. Then it'll pass in the value, if this condition is met, this Boolean value of, sorry, I misclicked that. So yeah, if the Boolean solved, if that's true, then it's going to print, you got it. What are you, a rocket scientist? So that's if it's true. But if it isn't true, and the user failed the game and couldn't guess all of the letters correctly in the Hangman game, then it's going to print so close, sorry, but the word was, and it's going to print the random word the computer chose, and then it's going to say better luck next time. So that is kind of the core logic of the code. And then the final part of the code is the main man method, which I'll let Aaron explain.
So, in addition to keeping track of all the correct and incorrect letters guessed, and displaying them continuously as you play the game, we've incorporated the most recognizable aspect of the real-life Hangman game, which is the picture. Just a side note, the origins of the game Hangman could go back to the 1800s, according to Google. But this is where we introduce the new method called the Hangman Image, outside of all the previous class and method blocks. This part just prints out a piece of the picture as you keep guessing incorrectly. Every time you guess incorrectly, not only does it keep track of your incorrect guesses, it'll draw this little picture, and there's 7 pieces to it. You want to guess correctly so that way the character, the criminal, doesn't hang from the gallows, which is the purpose of the game. If you see the arms and legs drawn of the character, you know that the game is over and you have lost. But if you don't see this image, you've won, but it'll also inform you that you have won or lost.
Okay, so now that we've explained all of the source code and how the logic of the game works, we're actually going to play 2 games, one where we win and one where we lose, and I'll let Aaron play those games.
Game time. So, it tells you the rules for the game. You just, rule number 1, click down here, guess anywhere on the line, and it'll take you to the same spot, and just start guessing letters. Let's go with one where we win. So, well, that didn't start off so good. I thought Y was one of the letters. Maybe we'll go with a loss this first time around. So here we have the gallow structure, and there's only, I can't read it. Guess. Here we have my incorrect letters that I've guessed, and it stores those, and it reminds you which ones you've already typed in, so you don't have to keep typing in incorrect letters. So we got one letter correct, but let's keep going. And we lost. So the entire picture is drawn here. It tells you which letters you got correct, and the final display message says, oops, so close, sorry, but the word was cake. Better luck next time.
So in that game we lost one. So now we're gonna play one where we win to kind of wrap up this video. So again, every single time the computer chooses a random word, and I can see the word here, but I don't know what it is yet, and these are all of my misattempts. So I'm gonna choose vowels because vowels are much easier to guess correctly for these types of games. So I'm going to go with A. Okay, there's no A, so it's starting. I'm going to try E. Okay, there's an E. Let's see. Let's go I. Okay.
Incorrect.
R. Not very good. Let's go K. This is getting problematic. Let's see. O. Okay, there is an O. Okay, let's try L. Okay, so there's two L's. Alright, then I'm pretty sure I know what this is. Alright, so let's just do W. Okay. W and then Y. And it tells us that we got it correct and the word was yellow. And it says we had 3 attempts left. So we finished the game with 3 lives left essentially, and we guessed correctly with yellow. Okay, and then it displays our little fun message here at the bottom. You got it. What are your rocket scientists? So that is our Hangman game.
Hangman in a nutshell.
So yes, this is our game that we've done for our project. So, and all the source code is here, and we've also added notes explaining the logic of what each part of the program does. So yeah, that's essentially it. Thank you for listening to this video and watching. And yeah, that's pretty much it. You want to have anything else to say, Aaron?
Nope.
No?
Catch you on the next one.
All right. Sounds good. Thank you.
Only went over by